8.6, the binomial theorem, part 2. So we're going to find just a singular term without having to expand the entire thing. So there is a formula, but using Pascal's triangle is your best bet. So we want to find the seventh term in the expansion of x minus 2 to the power of 10. So what we're going to start with is we're going to look at, for that to the power of 10, we're going to look at Pascal's triangle, and we're going to look at the row that has the 10 in it. So this is the row that we are dealing with. So that's going to help us expand this out and find the seventh term. And I always just keep a copy of Pascal's triangle. I write one out, usually up to 10, so I can just save my time later. But we're going to just write out that singular row. So we have 1, 10, 45, 120, 210, 252, 210, 120, 45, 10, and 1. So we want the seventh term, so we're going to count to the seventh term. So 1, 2, 3. Okay, I'm writing this on the wrong page. Oops. All right, now we're on the right page. 1, 2, 3, 4, 5, 6, 7. So this is my seventh term. So the way that it works is we're going to count backwards for x. So we're going to start here at x to the b, the 10, 9, 8, 7, 6, 5, and this is going to be x to the power of 4. And then we're going to work backwards with y, so y is 10 here. So 9, 8, 7, 6. So y would be 6. So I have 210 x to the power of 4, y to the power of 6. And then I'm going to plug in my x and my y values. So x is actually x. So we have 210 times x to the power of 4. And y is negative 2. So I'm going to plug in a negative 2 to the power of 6. So we have 210 x to the power of 4 times 64. So my seventh term is 13,440 x to the power of 4. And that's all you do. So using Pascal's triangle is the best. You can also use this formula. So you could do n of c k minus 1 is x of n minus k minus 1, y k minus 1, and k is the term you're looking for. So we would do 10 is n times c to 7 minus 1, so 6. X of 10 minus 6, y of 6, and then we would have 10 choose 6 of x of 4, y of 6, and then we get exactly to where we just were right there. So you can also do that too. If you don't have Pascal's triangle written out, then yeah, okay, that's probably faster. Okay, determine the fifth term in the expansion of 2x plus 1 to the power of 8. So we're going to look at Pascal's triangle at row 8. So we have 1, 8, 28, 56. That's not 8. 70, 56, 28, 8, 1. And we want the fifth term. So 1, 2, 3, 4. This is my fifth term. I'm going to start counting backwards. So 8, 7, 6, 5. This is x to the power of 4. I'm going to start counting backwards from y. 8, 7, 6, 5. This is also y to the power of 4. So I have 70 x to the power of 4, y to the power of 4. And I know my x value is going to be 2x, and my y value is going to be 1. So I'll just plug that in. So we have 70 times 2x to the power of 4 and 1 to the power of 4. Don't forget to distribute that in. So we have 70 times 2 to the power of 4, x to the power of 4, and 1 to the power of 4 is 2. Sorry, it's 1. It does not change. So 70 times 2 to the power of 4 is 70 times 16, which is 1,120, and then x to the power of 4. So that is my 5th term. Or you can use that formula, but I'm not going to do that. If you want to do that, you go for it. You do you. All right, and that is the last lesson of Unit 8 of Pre-Cal 30. So either you did this as Unit 1 and we're just getting started, or you just finished the course. Woohoo! You're doing amazing, sweetie. Either way. Okay, bye!